Alrighty. I'm gonna go ahead and post this Hangout on Slack so that that was incredible. We're projecting on the Apple TV right now, so we're projecting me, and I watched you and then walk past the camera. Also, it's very strange. It's a strange experience.
That was cool.
All right, I'm going to actually have something I left in my car to help you guys out. Second. Yeah. You're in the CSS section. Copy and paste that. it's not working 100%, try and make notes. Do. Nailed it. Just like how it's listed on the screen. Duh, Bill. Sorry, I thought this was up on the screen when I left. There you go, man. So just think about it. You're just making a new int array, right? So this is exactly why you do that. All right, so guys, one sec. So one of the biggest barriers to solving problems in computing is not actually the difficulty of the problem, it's just verbalizing it and being able to phrase it in such a way that it makes sense to you kind of procedurally. So breaking it down into English is a very important aspect in solving any problem. In fact, I think you guys are capable right now of solving whatever problem you need to. I've seen that in your homework assignments, the backend team. It's just, knowing what to do is the hard part, like knowing where to start, knowing where to begin. So one common way to overcome that barrier is called rubber duck programming. Rubber duck programming is when you literally explain what you're trying to do to a rubber duck. And in doing so, you unveil the flaws in your logic or the things you need to alter. So I bought rubber ducks for you guys. So each of you gets a rubber duck. On the back, I'm sorry. Yeah, yours are in the mail. Don't worry about it. They're on the way. By the way, buying a bunch of rubber ducks with your children is a terrible idea. They can't have one.
I have like all these butterflies again.
It looks like I have an extra one. So we have a rubber duck.
You're missing 8th grade.
I know, but most of the time.
Yeah.
You'd be surprised because a lot of the times, like when I used to work at like the support desk, you know, the problems that people would have would just magically disappear. And I'm pretty sure the only reason why that was because they were like stepping from the beginning through the whole process and then like subconsciously getting it right because they stepped through it in a way that makes sense. So I've seen this happen in programming before. It sounds really silly, and it is, but give it a shot. If you're getting stuck, just talk to your duck. I didn't mean for that to rhyme.
How are we going to go over this? Get a shot on the road.
Sure.
All right, so at a high level, before we even think about code here, what is it we're actually trying to do? Yep. Yeah, so like each element of an array, right? One way or another. And let's keep it that from just being like one for loop where we test one thing to the next thing, to the next thing. What's kind of the hard part of this? It can be in anywhere. Right. So it's not like you can just compare item number 1 with item number 1 and then item number 2 with item number 2, right? If you had to do that, you can kind of just for loop through it, be really fast, then we could go home, right? But here we've got what we're going to worry about. So in our brains, we can look at the sets 1, 2, 3, and 3, 2, 1. Kind of say, yeah, those have the same numbers in them. Right? But if you think about it, like as a human being, this one is probably harder for you than this one, right? And if I had twice that many numbers, it would like take you even longer to do, right? There's more to think about with this. So if we're thinking about two sets of numbers that are coming into arrays of numbers, what can we do about this whole ordering thing? Like how can we make this comparison? Yeah, explain a little bit more. Is that you, Mike?
Yeah. So if you sort them by numbers going up, then you can compare the two much more easily.
Yeah, so this is a really solid idea. Right now the problem is they don't have an order, right? So one solution to that is let's give them an order. And as long as they have the same order, it doesn't really matter what it is, ascending, descending, odds first, evens first, whatever, it doesn't really matter. As long as it's a consistent order, then we can go through and just check everything one by one, right? Does that make sense? So convert this first step into 1, 2, 3, 1, 2, 3, and then one for loop. So that's a great thought. Anyone take another approach, even if you don't have the code for it?
Mine wasn't this one yet, but I just did 2, 4, right, and then 2.
How does that work?
So like the first number I did a for loop for every character in its length, and then within that for loop for the second number.
So it's kind of like 1, 3, 2, 1, 2, 3, 2, 1, 3, 3, 2, 1.
Yeah.
In this case,
And I counted each time it matched. Like I counted it. If the counts matched the length, what the length.
yeah, so that's actually, those were the only two ideas I had how to approach this. But yeah, so I've got one that has 2 for loops, one inside of the other, right? And for every one of these, it's going to basically run through the whole array and see if it can find a 1. If it does, it's going to see if it can find a 2. If it does, it's going to see if it can find a 3. But at any point it doesn't find one of those, you can kind of say, nope, right? These do not contain the same numbers. But this first one was a 4, left hand, right? This first one was a 4, then you don't even need to check 2 and 3, right? Because there's no 4 over there, so it doesn't really matter what the rest of the numbers are.
There's one small problem with that though, is that if your second array contains more elements than your first array, you'll never know, right? Because if you have the inside loop, you're iterating over the first array, right? And inside you're iterating over the second array. So for every one, you're like saying if they're equal to each other. So you have to iterate over the largest one, right? Or you can check at the beginning if they're the same length, right?
What are the parameters that there won't be any duplicates?
Yeah, but it's not a matter of duplication. It's a matter of like the arrays being different sizes.
So I think that's what
There's no duplicates, and they're different sizes, and there will be a missing.
I think that's true.
So it will always be return false if it's
If they're in duplicates, I think that's right.
Because if four, like if you have 1, 2, 3, 1, 2, 3, 4.
Yeah.
Like if 4 doesn't have a 4, then it'll return false. Because it'll loop over it.
Oh, yes. Yes. I see.
Yeah.
But I think Scott's right. No.
Well, if there is a duplicate, then that would be a problem.
No, I think 1, 2, 3.
Yeah. If you have like 1, 2, 3, 1, 2, 3, 3.
No, no. Oh, it's okay. So duplicates aside, the problem eliminates duplicates, right? So no duplication. So say we pass in 1, 2, 3, and 1, 2, 3, 4. This algorithm still works. We just have to add a step to the beginning. It's like iterate over decide which array is longer, and then iterate over that. And if the other one's longer, then we just return false. That's true.
But I think it's true that if they're not the same length, then the answer is always false.
That's correct.
So,
Yeah.
Won't it check 1, 2, 3 and find the 1, 2, 3 in the second array, and
If you do
but it
that,
won't find that there is not a 4 in the first one?
Yeah, but what he's saying is that before we run those for loops, we return false if the arrays are at different lengths,
Oh, yeah.
like period.
So we would have to be more careful if duplicates were allowed.
Yeah.
Because then A, you couldn't depend on that length at all. And B, we tried to get more specific in the problem to say it doesn't matter if there's just at least 1 3.
Yeah.
They need to be exactly the same number of 3s, and then that turns into a tangled mess. So
Well, we could try to make this an array list problem in Java, and then just pop away the one that is
yeah,
when they match,
we could do the same thing.
which we might do later.
Should we write this out?
yes.
Did JavaScript do it any differently?
We'll write it out. It'll actually be interesting to write these two out so you guys can see what it looks like in both languages. But let's actually start with Mike's approach. That's going to be really short. So did any of you guys on the front end side try sorting? Okay. So if you go and you look up JS, how to sort array, there's a array.sort. Classic JavaScript. So let's build a function here called Uncharted.
Are we not sharing our screen anymore? Sorry, I guess my thing stopped sharing the screen.
So in JavaScript, we'll just log, say, Uncharted 1, 2, 3, and then we'll start with that. Okay, so the first approach, the Mike approach, would have basically amounted to sort both arrays, for loop through them, and return false if there are any weirdos. To the end without weirdos. True. Moving through, we hit a 4 and there's not a 4 in the other one, then fail. So, I think in order to sort, all we need to do is this. Let's actually do this. First equals first.sort, second equals second.sort. So the sort function is going to return a sorted version of whatever array we call it. And so if I console.log first, log second, What we should see is we're going to call uncharted with 1, 2, 3. These are arrays. I've got square brackets in case array list. So we've got 1, 2, 3, and then we've got 3, 2, 1. First thing we're going to console log is going to be 1, 2, 3. Hopefully we'll see a second 1, 2, 3, and then we'll output undefined because we haven't returned the values yet. 3 is undefined. So if we sort, which luckily in JavaScript we can do it with line, all we really need to do, as Mike said, is for loop through this guy now. How many numbers do we need to check?
We like to create this.
Yeah, you should. That's a good call. Very beginning. First length is not equal to second length. Otherwise, so this return is going to stop the execution of this function. So we're not going to move past if that's true. If that's not true, then we're going to go ahead and move past. And what's our check inside of our for loop here?
If first I is equal to second, or if it's not equal to second.
Yeah, so we're checking for non-matches. And if we get to the end and haven't encountered any non-matches, so if we run through the entire array and haven't found any falses, that must mean everything's true. I don't want console log. Problem. Whoop. Conveniently, we only have to deal with one for loop. The second approach. In Java. Okay, why don't we go over that one in Java then? Sign up for you guys for that.
This might be a little bit weird. So I took the first approach. We sorted the arrays. So we have unsorted. We pass in 2 int array parameters. And in the table we talked about where if the array's length is different, it can be the same. And the arrays can't contain 10 numbers. On line 45, 46, we're just sorting them over the length of the array. The second one doesn't, since they're sorted, we can make this comparison false. And if we're down here, we went through this entire loop without returning false, so we can return true.
Awesome. If you compare these two, I mean, structurally identical, a little differently, very, very similar.
Yeah. Like the JavaScript, it doesn't exist in Java. We'll get to this Java on this. But in JavaScript, there's something called type coercion. A number is kind of like a string. That double equals ensures that this type is exactly the same in both the type and value. Later. In Java, you don't normally have to worry about that. So, but
Could you do instead of the for loop, arrays dot equal A and B? The arrays once they're sorted.
no.
Two loops, so for and have an int I and int j and compare I and j.
You got a for loop. The other kind of for loop.
Yeah.
Yeah, you could do that. I wouldn't use the variables I and j because those are usually indicative of indexes in a for loop. Doing the other for loop syntax in Java, it's you give the actual value in the array. So it's not I anymore, that's just your number you're trying to get to.
Oh, could you reference that by I or j?
Yeah, so in this case, I stands for the current index, right?
Right.
So you can think of I as like, but if you use the other array syntax, so like for int I first, like that, it's not, the convention isn't followed anymore, right? Because I is not referencing the index anymore, I is the actual number in the first array.
Okay.
So like you would have to say, like for more clarity, you'd be like int number first, like that, right? Because that way it's more obvious to the reader what you're talking about.
Would you have to do that, or could you do that for like, for int number first, for int number, and then compare those two? Or
Yeah, you could. You could. So you could definitely replace the contents of this for loop iterator like this. So first number first, and then you could do this is actually more in line with the other solution that was proposed. So let's go look at that instead. So there's no real need for that. You actually need the index to look at the numbers because we're actually using the index because it's in sorted order.
Okay.
So we kind of need I for this one.
So you only needed one for loop. J. Okay, never mind. Oh wait.
This is the other approach that
Yeah.
you could take.
Yeah.
And I kind of just typed this out like real fast, so I'm not sure even if it works. We can actually test it, so let's test it. And sort it other. It fails. It failed. Let's take a look at this. Oh.
What?
I was always returning false no matter what. But yeah, here we go. Just make sure we have other conditions taken into consideration real quick. Let's just make sure this all works. Okay, good. It's always a good feeling when your tests pass, by the way, which is another reason to write tests, because they give you validation. It makes you secure in what you wrote.
It's like checking in algebra.
Yeah, it's very good. All right, but like Lindsay said, in this case, we're not really using the index. We're only using the value at the index, and we have an inner loop here. So we could use the alternate for syntax in Java. So you could say int first number first, and you could say int second number second here. Second number second, and then you can compare first number with second number. And check it out. I can refactor. I see my test still passed, so I know that my refactorization worked perfectly. Recorded like right now, and also I'll push this repo in a little bit. What's up, Mike?
So why was array stuff?
Arrays not equals. It's a little tricky.
Yeah, because my arrays is red too.
So it's array that equals, right?
It's arrays not equals, and then takes into arrays list.
Yeah, that's what I.
Oh, okay. I thought you were using, yeah, that should work. Yeah. For arrays that equals, if the two specified arrays of longs are equal to one another. Two arrays are considered equal if both arrays contain the same number of elements and all corresponding pairs of elements in the.
Yeah.
Yep.
Okay.
It looks like this is the cool part. because of this guy right here.
Oh,
We're looking at the actual implementation of the Java language right now. That's how it is.
Yeah, guys start doing that more often.
The sooner you'll be comfortable navigating between classes, programmer, right? Just get comfortable, like just diving in, like I wonder how it works. Boop. Here's how it works, right there. You know, it's pretty legit.
And what is it, command? I never remember it, command, command click, okay.
Yeah, you just click on
Also, reading documentation is up there as well. Things like, for example, sorting. You can actually, in both languages, you can make it sort in ascending or descending order. Or you can make it sort in arbitrary directions or whatever. Yeah, so build some sort functions. So instead of rewriting your own sort function, right? If you get to know how these things work, read just a couple sentences on documentation. You're going to have a lot more tools available to you. Yeah.
So, to talk about today's
Why are we all here, right?
yeah, right? So let's talk about what we have to talk about today, which is RESTful APIs. Have you guys heard about RESTful APIs before?
On our side yet, but we've been using RESTful APIs.
Those APIs,
Yeah, go ahead.
Most modern APIs are RESTful.
Mhm.
True statement, Ben?
Yes,
Yeah.
I would say it's definitely the most popular thing to do nowadays.
Oh, oh yeah, quick break.
Yeah, that's okay. Yeah. Do you have anything written up for this?
On our notes a little bit from last week.
Yeah, that Google Doc. This like you don't have anything to share, so
Oh, no.
this is good.
I also have a bunch of different.
Well, with this, what's in here?
Yeah.
Sample API documentation.
Oh yeah, cool. Okay.
But I need to log in first, so I'm gonna do that real quick.
I can pull that up. Or okay, if you have it up, that's good.
There's like an API tester utility, which is actually like I think really enlightening because you can see
Yeah.
like the inputs and outputs and stuff like that.
Oh, that reminds me of the Marvel superhero. Yeah.
Apparently, what Google Chrome has for my past.
We're also going to try and build something, right?
Sure.
Is Chorus going to be a problem with that? Can you make it not pretty easily?
Yeah.
Okay.
I don't remember my username and password, and none of my passwords are working. Oh, you know what? This is like some crazy password. Okay, well, I think that maybe I need to create a new ID.
There goes how I've got an interactive one with Marvel over here.
Oh, hold on, I'm gonna use my IronYard email.
Found it?
Yeah, it's not Battle.net. It's an account called Matchable. It's like for APIs that. God. Internet is struggling right now.
It is. Morning internet.
Welcome back. That's
Seriously, can you say that to like this?
Why on earth would you think this would be interesting to talk about?
yeah.
Because everything about it, yeah.
All right. So what I was hoping to do was
Let's come back to this.
okay. That's
We need
fine.
a little more of an intro.
I know. I'm not gonna like. Okay, that's fine. All right. So an API. API stands for Application Programming Interface, right? And that sounds really complicated. I would tell you it's capable of doing. It's an application programming interface. Right? That's not. It's way less complicated than it seems. APIs, in a general sense, that acronym is thrown around in the programming industry a lot. So not every API you'll ever see is exactly what we'll talk about today. But if you're talking about the web, talking about the internet, it certainly is this, right? So when we're talking about an internet context, you can think of it as websites that deliver data instead of web pages. I mean, you're not, like when you hit google.com, you don't expect a flood of JSON, right? You expect a web page. And then 90% of the time, when you're navigating around the internet, you expect to look around and stuff like that. To help enable that kind of behavior. See how that kind of works in just a second. Hidden an API endpoint is what they're called, endpoints. You can think of it as like just a URL, right? Instead of in a web page, what you'll see is data. It'll be JSON formatted typically. So you guys remember what a JSON object looks like, right? We've saved JSON files before. And we
Running guys, you remember JSON?
really like open bracket and then a key set of key value pairs separated by commas, right? And actually, Douglas Crockford, he has a diagram for how to like look at the railroad syntaxes. You seen those? Those in class I think the other day. What's next in right? Remember that?
Yeah, but it's really
Yeah.
cool.
Yes. Yeah, exactly. No, we talked about the different, like, the better computer scientist you are, the crappier your website.
Yeah.
Okay, so by that,
I suck at computer science. That's why I got 6 grade.
by that measurement, Douglas Crockford is like, yeah. So, like I said, APIs usually return data in some kind of data format. Most popular data formats are XML and JSON. We're going to be using JSON exclusively in class, pretty much. I mean, you'll see XML, but not in the context of an API.
Is that SAS is with,
SAS?
or is it SAS? What is it? You talked about some. I thought it was SAS. Never mind. I'm sorry. Never mind.
It's okay. If you think of it, if you remember, let me know, because I'm not sure what maybe you refer to yet.
XML is fairly common in the Java ecosystem.
Yeah.
Very rarely is it sent to a front end. So it's actually a big pain to like do the JSON.parse equivalent of XML.
It's way easier to do it with just
Java with JSON. Yeah.
Okay, so What's very popular in the API architecture world nowadays is to build your APIs in a RESTful way. Stands for representational state transfer. Protecting your APIs. It's pretty big things. I've broken them down here. Request semantics, resources, and statelessness. Okay, so those are the big components of a RESTful API. Yes.
So in terms of larger context too, think of this as, I think of APIs as the contract between a front end and a back end. So when you're thinking about these three properties that Ben just mentioned, you're thinking about them in the context of the types of questions you should be able to talk about, right? So if you're building a website that's like, you might want to be able to ask matches for this person, page 1, page 2, page 3. Building a restaurants app, you might want to say, like, what are the top restaurants, right? Or here, this person just rated this restaurant 2 out of 5 stars. You're basically making a contract between the front end and back end. These are the things I need to be able to tell you or get back from you. The back end needs to be able to respond with those things, and vice versa. It's kind of like the topics of conversation that the two can have together.
Yeah.
What we're thinking about here.
Move on to REST, actually. Do you want to go over an example, or do you want to go over REST first?
Yeah, let's go over some examples. There are a ton of APIs out there, usable both from front end and back end. And very often when you're actually building an application, and what we're going to be doing a lot of moving forward, like using APIs, but kind of layering extra information on top of them, right? So mashups are pretty popular at hackathons and whatnot, which basically means you'll grab 2 different APIs, like the Google Maps API and public bathrooms API. I don't know if that's actually. 2 different APIs and like overlay them on top of each other, right? And then people can like rate the bathrooms. And you can just take multiple sources of information, weave them together, and then use a combination of a front end and back end to build an actual application that does more than those 2 separate things did before.
Can you say that again? I'm sorry.
Yeah, so you can take, I mean, think of this not as like, this is how the information must be displayed in a chart somewhere, right? This is just data, stick it to a database on the back end, a list of restaurants, yes. So that you can search by chef and find out what restaurants they worked at, right? So you can combine this information and do interesting stuff with it in whatever way you want. So if you're thinking to build an app that is really easy to understand which senators have voted for which bills, is going to be that. Right? So it's either you're going to write it all down yourself, like you're going to store it in the database, have some other source. Source would very likely be, right? Is that data available that we can somehow pull in or display, render in the DOM, you know, do whatever we want to do with it, by the way, which is a really cool API.
Sure, let's do that.
So the US government has done a lot of that. Charlotte specific APIs that the city here has worked on recently. Those apparently very. So here's a pretty cool example. Actually, I don't know, it's a pretty lame example, but it's a pretty relevant one. Weather is one thing. This is like 101 for using APIs. If you want to get weather data. Current weather data, Weather Maps, Weather Channel, and all these guys have their own APIs as well. But basically, anytime you go looking for an API, find a URL. And Ben said a second ago that, you know, application programming interface sounds like this really, what you're basically agreeing on are the types of things you can talk about. And the way that we actually like is in URLs. So if you visit this URL, and here, I don't know if you guys can see this, but at the very end, whatever, weather, and then Q equals London, equals Charlotte, or Q equals, or something like that, right? It'll give you the weather for whatever place you put in. type in whatever URL you want. Or you can't be like, this is a place. And if you send tomorrow, right? So you kind of agree on the format of the URL, right? So like, where do you want to know the weather for? When do you want to know the weather for? But you have to agree on that. And once you agree on that, the front end can build URLs. If someone says, I live in Charlotte, what's the weather in Charlotte? Back end. It's back to the front end. So the act of designing an API, which you guys will be doing, come up with what these URLs can be, should be. And what a lot of people, what blows minds is that all of this is arbitrary. They're made up words that is designed to hopefully make sense in the context of the application. But Facebook's API isn't going to have URLs that look like this, because why would they? They're not dealing with weather. And maybe 2.5 is a different thing in Facebook context than it is in the Open Weather API. Using the Google Translate API, its URLs are going to look totally different than this. But that's not because they must. It makes sense for them to look different because the data is different.
One programmer that was like, what makes the most sense?
Yeah.
I think it's this. And then probably he said that to a group of programmers, and they're like, okay, and that's like the precedent set for hundreds of thousands of people, right? Like that's the way it works. I mean, I wanted to branch on this a little bit, but like, area of programming where it's not like transition to go from this is the way it is because this is how the language was designed, like this, like accept these facts, right? And these are universal truths. So we're getting into the framework to use things that other people have written. And when you get into something other people have written, you have to keep in mind that it's not that way because it has to, because that's the only way to do it. Not following the same patterns that you'd be following if you were trying to learn the language. We're getting into frameworks. That's the way that the person who made the framework decided to do things. It's not some like enlightened and you're not. I mean, the person who wrote it probably has a lot of programming experience, but it doesn't mean they're right all the time. And if things seem weird, it might not be. It might just be weird. It might not be your lack of experience. That's hard to know. First coming into programming, like what is weird and what's not weird. You'll get that sense later on. I guess what Luke and I want to point out in particular is that tasked with designing this, something like this, or you're tasked with coming up with something new, like my API on, right? I mean, a magical right answer is going to pop out at you if you knew more about programming, right? It would just be like what you decided made the most sense to you at the time.
I've been using the phrase consistently arbitrary a good bit recently when it comes to naming. Like naming variables, naming functions, doesn't matter what you call them. Thing everywhere, right? So make up whatever you want. APIs are the same thing. Make up whatever you want.
And this might be a stupid question, but is the API the URL too, or what? I mean, like, how is that correlated?
That's part of it.
Okay.
Yeah. So APIs live at specific URLs.
Okay.
And that kind of gets into restfulness, which I think is a great segue into the next topic, which is restful nature of APIs. So, what's his name? Do you guys know the guy who wrote the paper on REST? Okay. Well, there was a grad student somewhere who did some work on restfulness, and all of a sudden now it's like based off of RESTful APIs. In fact, the web, the World Wide Web, you can consider it as one giant RESTful API. So the biggest part of RESTful APIs, point number one here, request semantics. So I'm going to do a little bit of reading off the wall here. In a RESTful world, oh, by the way, when you are talking about REST, and you have uses RESTful, usually called RESTful. Right? It's just something that people say. I don't know why, they just say it. It's strange. So semantics are the most important part of RESTful APIs. In fact, that's what distinguishes RESTful APIs from the rest of APIs anyone's ever written. On the internet, roughly request is arbitrary. I made that up. From your web browser, follow the same general pattern, right? So get website, e.g., get http://google.com, right? This says to the web server, I am requesting the information at this URL. You know what? Let's make this bigger. This says to the web server, I am requesting the information at this URL, right? This is a website. 95% of links that you click on, another arbitrary percentage. Issue get request to another URL. The server interprets that request and gives you back a web page, right? So if you go to Google and you type in, like, I don't know, right? And then you click on the link, it's a GET request. So you made a GET request when you submitted the input, and then you had another GET request. There's a list of links in HTML. You have the anchor tags, right? And then you have the hrefs that go into the anchored elements. If you click on that, your browser will issue what's called a GET request to the server. Request at that URL. It'll be like, oh, he's looking for hammocks page. Let's show him the hammocks page, right? He to that page, right? So that's the whole loop, right? Like link Java, the server has to go and get some data from somewhere, like get all the hammocks, right, that we have in our database, talk about like any deals you might have, and then generate the HTML and return the HTML back to the front end, right? And then you guys work with the front end team to what it looks like. Okay.
Sorry, get is what's called a verb, and Ben's getting to this, but think of get as being like that they're sending back.
Yeah.
Like, I need some information from you. Could I get that information is what the get means here.
This is that you guys have used the internet before, right? So you kind of had experience. I assume you guys raise your hand if you've never used the internet. Yes. Okay. So hopefully you guys can like kind of connect what your experiences are with. Right? Like Luke said, you can refer to these things as verbs or methods. You can request verb or request method. Like Luke said, verb is a very appropriate word since this portion of the request describes your intent, right? This is what you want to be doing at this URL.
I just sort of short-circuited your whole flow. Sorry about that. I didn't realize it was literally the next paragraph.
Other verbs may, like reiteration is always good too, right? So we still got. Other verbs may include, and there may be more, post, delete, patch, and put. The two major ones are get and post. Like your browser supports get and post. It doesn't support any of the other ones. The other ones that you see here, they are verbs that are like framework specific. So your framework has to be able to support it, and your browser is not going to be able to submit that request by default. You have to hijack the request and submit it with JavaScript. So have you guys ever like filled out like a registration form?
Yes.
Like yes. I mean, 9 times out of 10, another arbitrary statistic. That is a post request. Yeah. You're sending data to the web server, and that's the whole purpose of posts. So when you post at the same URL, giving it information that you want the server to have. Fills out that form. You know, it's going to be like Ben Starrett, and then like password, and then email address, right? And then you hit submit in HTML called a form by attribute by posts, right? And then when you hit submit, the web page will the browser will send that data that you posted in that form to key value pairs.
You can make those required as well, right? So like it won't post unless like you've completed all the required information that you want sent.
Yeah, in modern browsers, that's part of the which field has the required attribute you can put on it. Correct me if I'm wrong. But back in the day, a lot of that functionality had to be written. Like you had to be like being clickable until all these fields submitted, right?
If you want, for example, a phone number field to only include numbers, special stuff on the front end, basically say
Yeah.
Right, has to include only number of characters.
The arbitrary URL that we have, like say we have a URL that's like bensterrett.com/ right? And we say if we post to ducks, that would mean we have a new duck that we want the server to know about, right? So then we're going to list all the ducks that I currently have. If I delete ducks, then it's going to delete into like which duck to delete in a second. Patch input is like if you had a duck and you wanted to update any property of that duck, like its name. Like if each duck had its own name, duck's named Ben, and I wanted it to be named Bernard, I'd be put.
Would that be in the constructor part of it? So like you create a new, and then you patch Ben to Bernard.
You very well can make a new duck object and have that as your constructor, the name of it. But this is kind of related. Like it's you could make your class have a constructor that's a good name, but it's there's nothing about the API that make you want to do that. It's just how you want to be able to make new duck objects.
Okay.
About the data, on every website you've ever been to, / in real life, there are basically that you can do data. And they map pretty cleanly to what Ben's got up there. You've got a social network for dogs, right? And you put your dog's profile page up there, right? You can register a new account, which is create a new duck. You can modify an existing, good, delete a duck. Get the duck, right? That's the form, yeah. So you can read the information, you can change one. Change is very like broad, right? Like there's probably 1,000 different ways you could change a duck. Where things are all that you can really do. Form you've ever filled out or taxes you've ever filed, right? Like anything that is data in the broader sense, those 4 operations are the 4 things you can do. Pretty cleanly, with a little bit of like terms just for internet reasons, those map pretty cleanly to these different tasks, or these different verbs. Get, post, add a new duck, right? So this is a sign up form or something like that. Put and patch, both mean let's modify a duck that already exists. Goodbye duck.
What's the difference between put and patch?
I see put a lot more than I see patch.
The back button before, and then instead of returning you to the like no, never the back button.
Forwards, always.
Right.
Never back.
You know, it like previous web page is like it says request like page trying to resubmit form data, right? That's because what happened was you submitted a form. Your browser is protecting you from automatically resubmitting that data that you had as part of the form without your explicit confirmation that that's what you intended to do. Protect you. And that's a general theme in API design and browser design is that people can abuse the system, they will. Like if you submitted a payment, for instance, post, and you hit the back button, you would not want is for your payment data to go through again. Like what if you pay for the thing twice?
Right.
I mean, the backend system should not accept that because you already paid for the thing and it should throw that request away, but you never really know.
I've had that happen before, where it did it twice, and I was like, because it didn't accept it the first time, or it didn't like show that it did, and I was like, oh my god.
Yeah.
It was a lot of money too.
So your browser, when you go to a web page, it's typically a GET request, which is never populate that.
Quick example.
Sure, man.
So I'm on Yelp right now. Left map, please. List of restaurants. Get, post, put, delete. Which one would it be? Yeah, so to get this list of restaurants, nothing changed. That's always first question in my mind. Is the data changing? Request. I'm just reading data. I'm not changing anything.
So the GET request should never change data.
GET request should never change data. And it's probably the most common request type. Just give me what you have, right? Mr. Tokyo's Japanese restaurant. Loading this up.
Get.
It's a GET again. What about if I'm a user and I'm like, Mr. Tokyo?
Put patch.
Yes. Post is how I would kind of do that. Weird thought, but it's a rating. If you think of a rating as an individual, do you agree with those?
Because you're adding,
Yes.
yeah, you're adding a new rating.
You're adding a new rating. It's modifying an existing like value, 4.5 stars.
Yeah.
Record in the database or something like that as a concrete unit of its own.
Yeah, like this restaurant didn't have a rating previously. Like it didn't have a rating for you, from you.
So let's say you
Right.
modify your rating then, would that be for patch?
Yeah.
That would be patch. Also, another one, what if I click right here, edit business info?
Yeah.
Right? Because there's already business info. Not creating new business info. Existing business info. And then if I'm the shop owner and I come in and I'm like, I closed. The actions are triggered by the front end. People are clicking links or clicking on stars or something like that. But we need a way in the person's browser to say, anyone else who comes back here should see that there's now one more rating than there was before, and it was a 5-star or something like that, right?
Oh,
That
right.
means we need to communicate the fact that they click that button with the backend, and probably stuff needs to change. That is why an API exists. And Yelp has a API between their front end and back end, so that one person can send up information that's probably linked with their account or whatever, send up information, things happen, and then other people come and say, get ratings, like the output of whatever everyone else has kind of sent over time.
What's up, Joey?
So if you have closed now, it kind of updates depending on the hour. Kind of, is that related to the API? Like it's getting the time and comparing it or something like that, or no?
Something that is like the server. So when you render this page, right, you know that you're rendering. What's the name of this place?
Tokyo Japanese Restaurant.
Japanese restaurant. Okay, so Mr. Tokyo Japanese Restaurant. This URL is going. What's the URL for this? It's specific. It's Mr. Tokyo Japanese Restaurant Charlotte 2, right? That's an interesting thing. 2. That URL is probably some sort of identifier in a database for this restaurant. The database has information about this restaurant, like the address, it has the phone number, a couple of images, right? It has time, right? The times that they're open. So, and this is the job responsibility of the Java part, is to get the information, this identifier, right? It'll get an object back which represents the data from the database. Right. Okay? Include, more than likely, start time and close time. Okay. I need to render this page, right? I have this data. Process the template and generate you HTML. And part of that would be the server would say, give the current time and compare it with the times that the restaurant's open.
Okay, so it's the server's responsibility, not any of those.
Correct.
And I would say it's, go ahead.
Just that it's a pretty clear usage of this server-side processing, but it's a mixture of the two. This could be delivered through an API as well, right? So an API could also tell you that information. When I look at this, I would see an opportunity to just do it on the server, right?
You also could think of if this page was open for 20 more minutes, that would change too.
Yeah.
Right? So there might also be something JavaScript or like an API call that happens every 5 minutes or something like that that says, is this thing still open on an interval, right?
Yeah.
The front end's like, is it still closed? Is it still closed? Is it still closed? Something like that. So that if we were to actually just keep this open in a browser and come back over lunch, this wouldn't say close down.
So
How cool would that be?
That'd be pretty cool.
can you think about it like Java for the backend, like pulls all the data? So it's like the database, right? Like kind of.
It interacts with the database.
So,
Okay.
yeah, so like on the Java end, and the pull the data from the restaurant from the API. Current time outside of the times that the restaurant is open, then print like the closing at like.
Yes.
Okay.
So that would be the case, sorry. So, but that would be the case. Oh, never mind, because it's still, what he said is still pulling data from the server.
Yes. Yeah.
The front end, this person is in Charlotte, or at least Eastern Standard Time. From Australia, this place is probably like, in this case, this place is always going to be closed because it's in Charlotte. There are other times where the time zone you're in might actually affect it, and it would have to be the client that kind of says, this is coming from this particular part of the world,
Okay.
in order for you to be able to say whether.
Because like you could have somebody in Australia who's dating somebody like, let's say in the States, who wants to order lunch or something for their significant other and like
Yeah.
lunch. You like, yeah, I mean, that would be a really random case, but
That's
like
cool.
maybe,
I like that.
yeah, it could happen.
Google Calendar does it. If you schedule an event with someone, it'll automatically kind of adapt to that. There's cases where there are things like that, where in order to do what the backend needs to do, just need to go with an input, what time zone you're in. Those places where when you're designing the API, you can't just say, oh, we'll just go by the time it is, right? Well, the time it is depends on where that person is.
Well, like you wouldn't get the current time from the API, right? You don't get like a restaurant.
Case you get the restaurant time.
Yeah.
You get,
Remember.
Like on your iOS, like, right, or on your phone, like it updates wherever you are.
Yeah, but it'd be difficult to actually get the time from the operating system in your web browser. That's a little bit separate. But remember, like, we're talking about, like, I just want to reiterate, because I think we're getting into a realm where, like, we should be getting from the server and what we should be getting to an API, that it's all arbitrary, right? Like, I want to, again, say that, you know, when I made the statement that, you know, the server should probably run this as a, you know, part of its template rendering process where it gets the current time, we've made an excellent point where maybe that doesn't happen, right? Maybe it just returns back something, and that something is updated periodically with JavaScript. JavaScript has to be able to consume an API call, right? So it could be that, and we could even, if we're going into this really deeply, we can actually see what it returns. Yeah, we might do that in a little bit, but designers of the website to determine this, right?
So post, delete, patch, and put are all, I mean, I know there's a conversation between front and back, but
Yeah.
it would be more of a job of the front end, right? Where or it doesn't change, like,
So when you talk about these verbs,
Yeah.
these are all statements. You can think of it like a conversation. These are statements that the front end is making to the back end. It's always initiating this conversation. The front end is like, if you think about web browsers, you don't go anywhere. Initiate, right? Like if you're on like Google.com, it's not going to like, it's never going to push anything to you. It's not going to give you any data. But you could hit, okay, go and search for this, and then request on your behalf using the data that you gave it. Web server. The web server is like, they requested these parameters. It gives you back your search results. The browser gets the request back and it forwards you to that new page. So how you interact with that web page, the most appropriate verb to use is click on a link. Verb is a GET request. If you submitted a form, it would be a POST request. Right? And it's up to the server to decide what to do based off of the verb request.
In front of you guys, this is why we had to continuously make requests to the chat server this weekend. Really speaking, in RESTful APIs, the server's not sending you a new chat message occurs and you're probably interested. The client to be like, hey, do you have any new chat messages? Right? That's why we couldn't just kind of as soon as they happen, but you have to.
Like, how would the client ever know about updates to the server? If you think about that, then like, right?
So do we like or patch or put in our code?
Our code, basically we're writing our code to receive a series of requests, right? So the front end guys and the back end guys on which URLs to put up. You know, like what web pages they have their home page, right? It's on the URL, like whatever.com. Then you have like maybe an about page or a terms of service page. Some guys might have like a users page or something like that. Is that be able to send back to the client links to those different pages. For these requests first. So if the client like has a form on it, we're gonna on this page we're gonna gather some data about it and learning more about ducks, right? And then like on the back end, it's like we're gonna send you a weekly ducks email address to this email address you specified. So the front end and the back end have to agree that like, hey, when I submit this information to a URL which has meaning on the back end, okay, we're gonna have this URL request. And when we receive a POST request at this URL, we're gonna take whatever data that was a part of the POST request and put it in our database for people who are interested in ducks. A process that goes through all the people who are interested in ducks and sends them an email about the latest.
So we actually should write some code in a second here. Do a couple of examples, and then we can actually show how we run it. Cool.
Sure. Yeah.
Okay, so here's a quick. This is using a random user API. This is one of my favorite APIs. It generates random people, so Alvin doesn't actually exist, but it just generates like numbers and passwords and all that kind of stuff that don't actually exist. This is if you're prototyping an app, right, and you want to pretend like you have 1 million users, right? Make 1 million GET requests. None of them are real. They have photos.
Are you serious? You can do that?
It's amazing. It's amazing. So, do is, and we did this in the front end. There's a URL. Paste it. So
You may have bigger.
as format here. Yeah, so this is JSON, right? Which is a big object, right? So this is the response that's coming back. Inside of this response, there's a results property. So you can request more than one person. So this gives you back like an array of people.
APIs have
And usually the front end and back end are arbitrary though. So it's like, as long as you're doing the same thing, it doesn't really matter. Usually JSON.
Any detail? This is very similar to JSON. These are vacuum quotes. Like, what JSON looks like, it'll look exactly like this. You just realize that these quotes also.
And that's just my browser making it look nicer.
Yeah.
All these different properties, and this is pulled from some database, probably random function on the server. We can get this on the front end and then render a profile page or something like that on the front end. So this one's really cool because you can just refresh and you just get different data each time. It has a picture, that sort of thing. So each one is different. That's an example of an API. Again, in the response, it's making a GET request to a specific URL. This is randomuser.me/API because that's what they told us to do. And the response that's coming back is JSON. So the backend formats it as JSON, receives it as JSON. You're talking in the same language here, right? You send a letter in Mandarin. The person on the other side can read Mandarin. That's okay. But if both sides can read English, you can write it in English. Doesn't really matter. What's the problem is if you send it, the person on the other side doesn't speak Mandarin, that's not a useful letter, right? So you just need to write it in a language that both sides speak. It's the most common choice for that.
Yeah, and
It's insanely cool.
And JSON is actually really cool as a data transfer format for JavaScript because the reason about like it's exactly the same as like what objects look like in JavaScript. That's a valid JavaScript object, right?
Yeah.
Okay, this is kind of random.
Yeah, what's up?
On Instagram, I always get like these random like messages or whatever that's like 1 million users right now or 1 million followers right now, like or whatever. They probably do that on the back end, right? 1,000 followers. And I'm like, no.
I'm not.
Like if you pay them for it.
Oh yeah, I mean yeah, I think so. I'm not sure exactly what you're referring to.
Yeah, I think she's like saying that this random generation of people use that data
Right.
to create followers and use them.
Right, like fake followers.
Oh, yeah,
To make
yeah.
it appear like you have 1 million followers.
The really good services like that actually just happen to be
Are you serious?
real. Yeah, but those cost a lot more money. So.
Actually, like a few years ago, Justin Bieber, 13 million Twitter followers, and then Twitter had like a large fake accounts, like I think like 8 million.
Yeah.
Like a large percentage of his followers were not even real.
Real. Wow,
Yeah.
that's gotta like bruise his ego.
Yeah.
So let's move quickly through a couple of other examples. If you're looking through API documentation, the number one thing that I always look for is the URL. Copy paste the URL and just start getting data and see what it looks like. For good APIs, there's going to be documentation that says these are the things you can do, and these are the URLs to use when. Right, so OpenWeather, we talked about that. The random user API. It had specific parameters that it had. Yeah.
Use most APIs. Does the creator usually?
And whether they're optional or not, right?
Okay.
So here it would be required to have this Q equals, which is just going to be short for query. But there's going to be documentation down here somewhere that says, if you want to do it by lat long, there's, instead of a Q, you can put lat long. They have their own city IDs that you can use. So there's all kinds of different ways you can search for it. And all you need to do is just look at it and say, oh, okay, so instead of put zip.
Can you put these websites, like the one that generates everything, like, and the weather one on Slack?
Yeah, we can share all these links. Yelp is an interesting one because they actually have several different APIs depending on what you're trying to do. /v2/search, and then specify a term. So Q equals, instead of Q equals, you can give it a term, limit for the number of results to limit, right? There's like all these different things. Here's a sample URL if you wanted to just copy and paste that. For food in San Francisco. Food, or you change San Francisco, it'll give you something different. And that's just because someone agreed that that should be what it's called, like Ben said earlier. Or Zach. Yeah. They also have a business API and a phone search API. Those, all it means to have 3 different APIs is you basically got 3 different, right? They do 3 different things. Speaking of lots of APIs, Google has APIs. One that's really awesome is their Google Translate API. So you can send it text in a certain language, say I would like this in Russian, and then it'll send back whatever that text was. So it's like you went to Google Translate's webpage, but your computer can do it for you. Final project down in Charleston that I thought was actually awesome. Typing something and it would live translate it but you could actually have someone typing into a text box, and as they're typing, those requests like, how do you say this in Russian? How do you say this in Russian? How do you say this in Russian? Kind of
Cool.
being typed in Russian at the same time. Or
It just came out with like an earpiece that does that too. So like if somebody's speaking
Yeah.
to you, they can like translate.
saying, like, another thing that's just ridiculous about this is that translation is really freaking hard to do if you're doing it yourself. You couldn't do that over the course of this 12-week program. You couldn't come up with a really solid translation service, right? It's hard to do. But if you can put together a URL, the best one in the world. And you don't really have to do much more. It's like this much code in whatever language you want to. Gives you a lot of power to do things, especially like Facebook has one that lets you do graph search, which is basically how you search for people. Their API, or their URL, excuse me, graph.facebook.com. I'm not exactly sure what that is, but URL that you put it, right? And so this will allow you to search for people on a bigger database than you'd ever be able to assemble.
So like when people create apps, I was always wondering if you do certain things or not from the companies, but like let's say you create an app, just like it's like a chat app, and you request. So the developer for that app basically has like the Facebook API. And do you have to get like permission from Facebook to use the API?
Usually, and they'll have terms of service that you can't just, for example, like they have limits as to what you can do, and they'll cut off your access with you.
This is getting into pretty deep API stuff,
Yeah.
or like intro to API lesson. Learn more, you can look into OAuth. That's how they authorize requests in Graph API. Basically, there's like permissions for everything. You've been like logging with Facebook before, and like forwards you to actually Facebook, and it's like this app wants to be able to do this. You click yes, and then it redirects you back to the app. Your app will look at where it came from, which is Facebook, and see that yes, they were okay with this, and then it'll give you like a special access key to try and request stuff from the API. So if you're like, I don't want them to be able to do that anymore, revoke that key, the key's no longer valid, your app tries to get it, it fails.
There are also crazier APIs. Ben has some for some video games. Marvel, for some reason, still haven't figured out why they have this. You can request information about all their comic book characters. Yeah, and you just get back, again, a JSON object. This did something with this last time in 3D, man, I think is probably still haunting all their dreams because it's the first thing out of like thousands of superheroes. 3D Man's the first one, so he just showed up when things were going wrong. But they have images, they have all kinds, like an unbelievable amount of information about every superhero, including how they fit into the plot and whatever. Very minor character, don't worry about it, no one knows who he is. Okay. Yeah. Like, if you need data, very often, it's either you build it yourself or you get it from somewhere else. APIs are commonly how you do that. Last example, and we'll see the internet's going real slow, might not load stuff, but govtrack.us is a really awesome website for government transparency stuff. And this is built by the US government. Voting records for Congress, you can get who voted for what. You can look up individual people and about them. And then the question is, what do you want to do with that, right? And you can do whatever you want. So a lot of this is making data available, and then what you do with that data is what your application actually is.
Think of like in the Java class, we've actually written and read JSON files, right? The same thing, except for instead of just like getting it from a file, you'd be getting it from like a URL somewhere. Remember, we had like a contacts file that was like just JSON, right? If you imagine that same JSON file exists in the program, if it was like at people.com/contacts or whatever people, your app would just have to change to read it from there, pull it in instead of read it from the file.
Questions at all?
Sure. Do you want to finish up this lesson real quick?
Oh yeah, I'm sorry. Yeah.
Sorry.
Let's do it.
Okay. So I wonder if, like, we're still live.
The internet, I'm losing here.
Any questions though? So far, does this generally make sense?
For a job right now.
I think it might, I mean, like, I'm kind of confused a little bit, but I think it, like, once we start working with it all.
Very good skill to practice designing APIs, which we're going to try and get into some. In Charlotte, we're going to be able to get into that because we have you guys synced up on the same schedule on designing APIs, which is not only copying and pasting from someone else's website, but hopefully after you've seen enough of those URLs, you can start to think about your first step is probably just going to be, and you'll be like, wow, that's embarrassing, right? Got it, you'll be better at it, you'll be better at it. You'll figure out what makes a good API. Still carry on. It's kind of the same as like naming functions clearly and well. Function that's going to be used by the internet. So a lot more people.
Like the basic tenets of RESTful APIs, one of the questions you will be asked in the next year. Right? Like, pretty major thing. People are writing APIs all the time. Creating APIs is a big deal, right? So just real quick, and then we're gonna get into some code. I want to go over this, like some keywords that you'll see, like resources. Like we talked about, like website.com/ducks. Conceptualize that ducks endpoint as a resource, and to that resource you can new items, all the items of that type. You can get all the ducks, you can update them, you can delete them. A resource from a RESTful standpoint is just a query with different request verbs and have it do appropriate things, right? At specific URLs, and the ducks resources, and they usually map up with the name of the URL, right? Because the whole purpose of the URL is to be as semantic as possible. Okay. And then last but not least, statelessness. Statelessness means that each request is completely separate from any previous one that you've made. It's essential for a properly functioning website in today's world. So requests once, will return the same data times, right? Because you have to think of it like things are happening in parallel. Data, but so are 10,000 other people requesting that same exact data. And so there's nothing, who am I? It just is, okay. And that'll make a lot more sense, I think, as we progress, as we look into examples, but just keep in mind that statelessness is a thing in REST. Okay. So, code examples.
Yep. What's a cool app idea? We're not going to use an existing API. I think we'll just make it to that data from something that then puts together and render it in JavaScript. Very similar to what we've already done on the back end, but we'll design the API and we'll see how bends, basically how we hook the API together in the front end and the back end.
City of Charlotte.
Yes, okay, so coffee shop,
Yeah.
or let's say there's,
This
let's do something really basic.
Yeah, let's just, we're gonna make up the data. And we're gonna just
Honestly-
think of everything,
The Starbucks app is the best app I've ever used. Like, it's amazing. I use it like every day. And if every coffee shop or restaurant had it, I would like be everywhere.
Let's do like you can add coffee shops and then you can like rate coffee shops based on cost.
Yes.
$1 to $4 cents. I mean, we're probably not going to get all the way through this, but hopefully it'll be enough for it to make sense.
Yeah. Okay, so we want, let's write this down.
I have a whiteboard. Oh wait.
He doesn't.
We both love whiteboards, so. Okay. What do we want to be able to do to get our, what do we want?
And what data do we need, first of all? What are the-
Google Maps.
So let's say we're not using existing APIs.
Oh.
We're just going to deal with our own information here.
Yeah.
What are the types of data?
We need location,
Places.
places, location, price.
So let's say price. Yeah. And we won't worry too much about like latitude and longitude and all the complexities of it. A coffee shop,
Their
And-
menu.
you'll be able to rate them. We only have an hour. So.
So we have price, which could be like in Google, you have like prices rated in dollar signs, right? So this could be like a number between 1 and 5.
Yeah.
This is right?
Or a number in our case, rather.
Right?
Yes.
Okay.
Name of the place.
Yes.
And if you want to rate a new place, or sorry, you want to rate the, so you can basically do two things on this website. You can create a new coffee shop, rate an existing coffee shops too.
You want like any subsequent rating, like we're gonna keep it simple, like it just has one rating. Ratings.
Yeah.
So we were rating. Between 1 and 5. One star to 5 stars. Okay, so we have price, name, rating.
I'm just thinking lists must be super simple. Like, they only need like really simple things.
It's fun to start thinking about the sites you use on a regular basis with apps you use on a regular basis in terms of the information that's actually being exchanged. It's not that complicated, actually.
Yeah, like, it's amazing.
Okay, you want to go to endpoints now?
Sure. Is this all we want to store?
Let's say so.
Okay. Coffee shop, right? So in the backend world, this is the data we want to store. Store this data.
Classes?
Yes. Thank you so much. So this would be, this kind of maps up to a class in the backend. So we'll be making a class. Right. How do we interact on it to the backend, right?
JSON.
Well, we deliver the JSON with these endpoints. So let's talk about the endpoints that we're going to be serving, right? What GET requests we're going to be serving first? I'll talk about that first.
What data do we need to be able to get?
Price, name, coffee shop.
Okay, but if we get the coffee shop, we get price, name, and rating for that
Okay.
coffee shop, right?
Right.
So let's focus on not the individual fields. So you guys don't normally go into like that level of detail. Let's just focus on what we're going to get at the higher level.
So again, conversationally, what do we need? The coffee shops, probably, right?
Yeah.
That'll include more than just the string name, but
So the URL will be like slash.
Does that make sense?
That sounds good.
All right. Slash coffee dash shops. Does that make sense?
Yeah.
Mhm.
And what would we expect that to return? What type of city?
Coffee shop.
Package.
Coffee shop.
Shops in your your area.
Keep it simple. We don't have, see, a coffee shop doesn't have a field for like location right now. So we can't actually say coffee shops in our area. It's just going to be the coffee shops we know about. Yeah.
How many will there be?
Oh my god. Yeah, no. Let's just be like,
I mean, how many, like, in the context of our app, how many will there be?
let's say 5, just to keep it simple.
Well, when you begin,
An arbitrary number.
fine.
I mean, it's an arbitrary number though, right? Like, there may be 0 when we start off, but there may be 10 by the time we're done, if we actually sat there and typed stuff in, right? And send this back as one object, as like an array. Yeah. And then that array could have 0 things in it, 5 things in it, it doesn't really matter. Front end's just gonna loop through it. Like we do with chat messages, right? How many chat messages are there? We'll loop.
Question for the back end. Would we need to make coffee shop JSONs for each one of those coffee shops, or would there be, I mean, obviously, like, you put them all in one, right?
yeah, so remember how we issued and deserialization of JSON into a file?
Right.
It's going to be exactly like that. So we used a library, job library in our case, to serialize and deserialize JSON.
Yeah.
What we're going to do is we're going to just take a new, we're going to serialize it to return that data.
Parse it on our side, to turn it back into an object. Get coffee shops, what else do we need to be able to do?
We're going to go get a specific coffee shop, right?
Oh, we could do that.
We did. We could get /coffee.
Yeah.
Be able to reference a coffee shop by its name. Let's say /coffee/ coffee shops. Oh, I don't know why I said that. And then whatever name the current coffee shop is.
You could do the same thing for like ratings too, right? Shop that's the highest rated coffee shop.
Yeah, you could do that if you wanted to expose that endpoint.
I mean, you have to be able to do that in order because you just call that name. Like you can exchange name for price or rating.
No, you don't have to do anything like that. It's all up to you.
So why would you name it name if there's a class
That's how you want to search for
There is
it.
a field on each coffee shop called name.
So the whole thing's a class category.
Yeah, this is a class, right?
So then field then.
Name.
Right.
Yeah.
So then I should be able to exchange name for price, which is also a field, right?
Well,
it depends on what we're trying to do with the API though. Here, the purpose of this endpoint is to fetch a specific coffee shop. If we wanted to say coffee shop / $1.85.
That's what Weather did, right? Like they just changed it up.
Yeah.
Yeah, exactly.
Yep.
So in this context, name or whatever's in that spot would be our endpoint. Okay.
yeah, this whole thing.
Okay.
And then let's say we can post something too.
Okay.
Coffee shop. Now let's just settle, let's do that for starting.
Okay. What data do you need to be able to send?
When we create a coffee shop, what do
We
we need?
need price, name, rating.
Yeah.
So anything, in this case, new coffee shop. Everything from the front end. So there's probably going to be like a form with some text boxes and that sort of thing, so that we can get those 3 inputs, and then we're going to JSON.stringify all that, pass it over, and they're going to be able to deserialize it on their side.
Oh,
If not longer, someone clicks on a map and we get a lot longer than that, we can send that through too. You guys can save location. Again, it's all up to what we need to be storing. And then it's a matter of, okay, how do we actually get that data? It's someone types it in the front end, or we get it from an existing API. Those are probably the 2 most common answers.
I thought it was really cool.
Yeah.
All right, so what we're going to do now is Luke will get started on reading the JSON, and I'll get started on the endpoints. Okay. So
I'm picturing this as like two separate pages probably. So there's one that is lists out all the coffee shops, and then there's another one that's view a specific coffee shop. So one page, but I'm going to kind of split it in half just so I don't have to duplicate a lot of for the purpose of time. But I'll just put like so the top could be one page, the bottom could be another.
Look, I'm gonna create a Heroku app for this. Is that cool?
Sweet.
All right.
That's more than cool.
Is it more than cool? You know what's cooler than being cool? That's true. That's exactly what I was going for.
All right.
Alrighty. So what we're gonna do now is look at Heroku.
Do you want to talk or?
I don't know. I think we both have to kind of talk simultaneously.
Let's actually we could be writing it up and then we can just kind of go over it.
Okay.
In the interest of time.
All right. So this is just the easiest Heroku. Like Luke said, in the interest of time. Shortcuts. I'm going to share my screen first of all. Oh my god! All right. So just copy the code from the Heroku's Getting Started on Java because it gives you a nice boilerplate beginning of a solution that works with Heroku already. To go through these steps, we did this on Friday. But to go through these steps manually to kind of get a good feel for how you would set up a Java app on Heroku. But for time's sake, we're just going to do I'm going to clone the Java Getting Started direct. Whoa. Oh, it already has did that last time too. I'm going to create an app that hosts this stuff. So I was given the URL hiddenspire54138.herokuapp.com, right? So if you git push Heroku master now. I thought shift double click maximize your window. I'll have to look into that. Okay, so do Heroku open up a new web browser that is our particular web page. 2 seconds, we have a website on the internet, right? In my humble opinion. All right, so I'm going to open up that project inside IntelliJ. We'll take a look at what it looks like. Now, one of the biggest reasons why I decided to use this is because Heroku happens to use Spark, which is a topic of refocusing our energy. When we learned about the web app stuff. Import it as a Maven project into our current.
Is there a reason we chose Maven over Gradle for this one?
Because what we downloaded from Heroku was already in a Maven format, right? Okay, so we have our POM. We can check out our POM. It uses Spark version 2.2, so hopefully there's no documentation problems here that we're going to come across. So our main method here. Now, this should start to make a little bit more sense. From Friday, we didn't really discuss GET requests or POST requests or anything. Amount of detail. So in this case, we have this /hello endpoint, right, which takes in see this method has 2 parameters. There's a string here. This is a little bit strange to see at first, but this is a function that doesn't have a name, and its only purpose is to be this parameter. and then after it's this parameter, it doesn't have a purpose. We're not going to call it again. So this is a concept in programming that sometimes called lambda expressions. Not that intimidate you or be confusing. It really just is a parameter that is an object that accepts a request and response and returns this.
And
So
you know it's anonymous because there's not a name in front of it.
yeah, yep. So you're going to call this inside. So if we look at, maybe we can take a look at get.
Can you make that a little bigger?
Yeah.
Sorry, Ben, I didn't mean it.
So we have this. The second parameter here is a route, and a route is a what's called a functional interface. To that in more detail later. Know that this represents an action that you perform when you go to this URL, right? So if I go to my web page and I go to /hello, also if I hit /, which is shorthand for just the right, we're going to do a couple of things where we're going to build a hash map here. We're going to fill it with one value called a message, and it's called hello world, and then we're returning a new object called model and view. That hash, and we're passing it a template. So what it's going to do on the back end is take that model and that template, smush them together, and build you HTML. And at the end of the day, you're going to get this page, right? And weirdly enough, I don't think that they even use that hello world message in the template. It's just something they decided to put there.
Sorry, do you want to go through targeted object? And I can render that in the front end? Your flow.
I was thinking we could like serialize it in one of these, like it's going to be just a string. Yeah, that's going to be fine. So like, let's say what we agreed upon is a URL at the get endpoint, right? So correspondingly, we need to be able to do something at the coffee shop's URL. So we're going to do get shops. Okay. On line 23 here, we're going to have a request and response action that happens.
So we create an anonymous function.
Yep. Is to return a string. The string is going to be an arbitrary object. Look, let's store objects of type coffee shop. So let's build a coffee shop class, not a coffee shop class. I don't know, it's a coffee slab. I don't even know what's going through my mind right now. Okay, so remember that the data we wanted to store shop. Why is this weird?
Keyboard.
So Chrome works. What? All right. That's a nice little thing that happened right there. Okay, so we have, let's make a private,
String name and then two ends.
string name, int, we have private int price, okay? So let's generate our getters and setters for all these guys. Boop. So now we have getters and setters. Let's also generate a constructor.
Static, correct?
Correct.
Okay.
Because each coffee shop has its own values. Good job. Okay.
Thank you.
Okay. So now we have a class, a coffee shop that we can return back to the client. Now is actually return some JSON back to the end user, which is just a string. Okay. Now, what we have to do in order to do that actually is import, parse, and read JSON. Remember, we did that in class with file input and output. So let's go to let's actually use something called JSON to do that. Oh, it's probably a instructions here on how to install using Maven. library that Google whole job is to read and write JSON. Okay, so check it out. It has this XML in here. You can copy this XML and paste that into your POM. All right. So we're gonna see here. I'm gonna enable auto import now.
It's all running, guys.
About the technical stuff we got to do, but it's part of the library we have to install before we can serialize JSON.
And you kind of set this up at the beginning and then it's there.
Yeah. So we have included JSON in our libraries list here. You can see it here. I enabled auto import, so when I update the POM, my libraries are going to import in IntelliJ. If you didn't do that, you have to do it manually with Maven, the command line utility. So we go here to main, and let's see, JSON. Actually, what I'm going to do is Google a basic use case for JSON because I don't remember exactly the syntax. It's really straightforward. JSON. We have an object here. Let's build a coffee shop here. The coffee shop, coffee equals, they spell it right, equals new coffee shop, right? Let's give it some parameters for its constructor. Let's say it's not just coffee. Its rating is obviously 5, and its price is like, honestly, yeah. Like it's not like the most bourgeois coffee shop, but it's up there, right?
What if you wanted to create just wanted to create a specific example or a specific coffee shop? Could you do that there? Do you just do the constructor there, or would you just constructor there? You'd have to make that in the class.
The constructor is something you define as a part of the class.
Okay.
Yeah, so you have to you can use the constructor here, but you cannot define the constructor in here.
Every new coffee shop under here?
Not necessarily. Soon, what I'm going to do is actually, with our post request, I'll build, like, add new stuff to a coffee shop.
And because we're getting the coffee shop.
Now, just returning an example that Luke can use.
In the basic one.
Yeah. Okay.
So check it out. I'm going to take this new JSON object. Literally, we can just return this. This is going to return a string. It's going to respond with. So just like we returned a string up here to hello world, return a string, which is the JSON representation of this object. And execute this. Address. I'm going to upload this to.
Oh, I'm sorry.
Yeah. Hold on. So I open this up on localhost port 5000, and then I can do coffee shops. JSON. It's a little bit more like how Luke is going to mean to consume it. Let's make an array list of coffee shops. So array list coffee shop equals new array list, right? Now let's just say what we want to do is return shops. Okay. We have private static. I did that strangely, but what we're going to do on GET request right now, just for and do shops.add new coffee shop here. Okay, and then we'll restart our library.
I don't do
Can you go to the top of your code again?
Because we're inside a public static void main, and we're just going to use this coffee shops as like. Right. Okay, so we refresh this, and we have, instead of being one object, now it's an array of objects. You see the difference was it has, now it's square brackets. It's going to add another one, right? So this is the danger of the request, is that every single time you refresh it, you're going to have more stuff. And this is not typically what you would expect in a GET request, right? A little bit, but for now, when we reboot our web server, all that stuff is going to go away anyway. Stored in memory, so now if I just refresh it, it's gone. Okay. If it were in a database, it would be a different story. It would just keep adding to it. All right, so now that we have our basic data being returned in the format that Luke is going to expect it in, which is an array, we can add everything. Being committed to Git. Well, no, we're not going to get it. We're going to commit it to our Git repository. So it's adding JSON library and the coffee shops endpoint, right? We're going to git push Heroku changes. Heroku is going to receive this push. It's going to see that the POM has all of its dependencies. One of the dependencies is going to be JSON, and it's going to compile it on the server and deploy it. Dino is inspire 54138.herokuapp.com.
Inspire 138.herokuapp.
38. Inspire-54138.herokuapp.com. For you. You want to see it like that. Make sure we still have internets. We do. We literally just deployed it. I guess it's taking a while for the dyno to react.
So as soon as I can get this to load up, which should happen any second here. I mean, what's awesome is that Ben just wrote this code, deployed it to the web, and now I'm going to be able to consume it, which means we're actually building things that resemble very real applications, right? No longer are we just writing throwaway functions that no one else can use and that sort of thing. Different programs talk to each other, which is the nature of what mobile applications and just applications in general.
All right, guys.
Good.
What's happening there is that locally I didn't have the environment variable set up, and so I just hard-coded the port number, but Heroku expects to be able to pass in the port number through the environment variable, so I had to, that's why it was hanging. Should work a lot better. Refresh this.
Hey, I got it.
Yay. All right, so slash. Okay.
I did.
So the next step we're going to do is make it so that the GET request doesn't update the data.
If I refresh this, we'll get the second one.
Yeah.
But importantly, you'll notice this looks a lot like data that we got, right? I mean, this is JSON. I can write my application on the front end to JSON parse this data that we're getting back using the same URL. Which is the web page. Am I good to go?
Yeah, man, do what you gotta do.
All right, so I'm going to copy and paste this because I'm going to need it a little while. put together some stuff. Just go through this really quickly. I've got a basic HTML page set up. A style sheet, which has nothing in it, and app.js, which also has very little in it. So we'll take a look at that in a second. Like I said, I kind of broke the actual page itself. I went ahead and our application. This top part is going to be the list of shops. That's the part we're working on right now. And then the idea is when you click one of these things, change the data down here. And then I guess I could add a third one for like adding a new coffee shop as well. We're actually going to ignore this shop viewer part for now. The first thing we need to do is just list all the shops that are coming. And you'd want everyone who went to this page to be able to get the same list of shops. It goes away for everyone, and so I have the shop that shows up for everyone. So this is going to be pretty similar to what we've done at the front end already, except we've kind of made up our own URL now. I've got an ID on this UL. And I've got 4 kind of hard-coded LIs in there right now, but I'm going to want to dynamically add those, create those elements for every coffee shop that we get in our response. Cool. So when we say request.open, we've just kind of copied and pasted what people told us from API documentation or whatever. So this is the important line, but this line so I've got this kind of URL stuck at the beginning, but /coffee shops at the end. I'm only putting that there because that's what Ben put in his server. I'm only putting get here, what Ben put over here. Making up get, I mean, there's a time and a place for get, but here we've chosen to use get, and we've chosen /coffee-shops. And we've chosen that on the back. So if he changes the name here, I change the name here, it's going to work just the same. So if I, let's see, so I make that request. Just console logging this guy. We can log it.
Read it.
JSON.parse. Yeah, so we're going to read it in, we're going to be reading it as a string because Ben sent it out as a string, a serialized. So I need to be able to do shops equals JSON.parse response text. Response. That's just a variable. Console log shops at first. So that I need to send. Almost forgot it. So as soon as the page loads, I'm calling the get coffee function. My WarCry, of course. And then that's going to set up a AJAX request to this URL, make a GET request to the endpoint that Ben set up. When I get the response back, I'll JSON.parse it, and then I'm going to console log it. How many copy shops would I expect this time? Probably 2, unless Ben's made the request once.
I'm just thinking to myself, we gotta set up cores.
I'm gonna love the face plan.
I was like, I'm not sure if we should have to do that, but we do have to do it. I mean, yes.
So cores is a mess. It's a good thing, but and I tried to do a live. This has gotten us a little weird.
Yeah, that's for sure.
The general idea is that front ends and back ends, you don't generally want any arbitrary web page to be able to start making requests all over the place. It's mostly for security reasons, which is it's kind of a deeper thing that we'll go into today. But if you see this problem, if it says no access, control allow origin, it's like dork speak for the server's not set up to accept your request.
Dork speak. Oh, lordy.
And this does happen. There's a couple tricks to get around it sometimes, but usually it just means things aren't set up to do what you're trying to do. Usually it's a server-side problem.
Website. The main? Yeah.
What this does mean, though, and if we go and look at the network tab on the front end, we can see that my request is happening. Back at 200, surprisingly. That seems like that shouldn't be the case. But nothing's rendering, nothing's console logging because of this error.
This used to be like just in their documentation, but apparently they removed it somehow for some reason. Cross origin.
I was looking at it and then started.
Oh, the screen.
Yeah. I saw your name. Joe, the dark side.
All right.
Do you need to actually add the headers manually, or is there just some like middleware that you can easily add in?
This middleware. On right now.
There are now 5 not just copies.
Not just copy.
There can only be 1.
So we response dot access control allow origin. Okay, so we pushed it. I'm not gonna really tell if it worked or not until Luke does it. It's not done deploying yet, so.
Good news about all I need to do to test it is refresh my page.
Yep.
And then, oh, we're gonna be starting over at like a small number of.
Did you? That looks like what you typed. Did you type that in?
Back up. My computer is.
Likely.
Yeah. I mean, it's still struggling to just refresh this page right here.
Let me just, while we're sitting here, double check access control allow origin. Yeah, there's no typos, so that should be fine. Let's check the internet to see if I got internet still. Just if there is a way that you have to.
Did you forget to return something from before?
It could be.
What is happening like?
Heroku logs. So, oh, you know what we can do is do this locally. No. It just modifies the response object. This has to be done before mapping, like request mapping. Before request mapping, so it's a little strange.
Extra semicolon. I thought you had an extra semicolon on that line, but I'm probably wrong.
No.
That why the application errors come up?
Server-side issue of some kind.
Oh, you are correct.
So maybe somebody is like updating the application when those come up.
Likely than not, an error occurred though, so you Java side that didn't work and generated an exception or something like that.
Yeah.
I'm having a really weird experience on Instagram lately where like my pictures will only show up sometimes, like certain ones, like it'll cut off like certain like dates. And I don't understand why unless I think I can figure this out.
Did I like
Unfortunately.
accidentally? So it's complaining about line 26, which was this static file guy, which I didn't think I changed, but I may have like unwittingly like swap those lines around. Oh, you know what? Maybe you need to specify the port beforehand. So I'm messing up with this indentation thing. Sorry about this, guys. We're already running it. It's better. We're going to just push this. Heroku.
One lesson learned from the Charleston campus most recently was that usually if you're building an app, it needs to work. Right? So they take different times, like in a strange way. Usually getting the Java set up takes a while, but once it's set up, whereas the JavaScript is pretty easy to get going, like you just throw down some HTML and you can kind of iteratively build on it. So it was, one of the things that people commented on was that it was a huge time saver if you agree on the API at the beginning, even if it doesn't work yet. Start designing around the fact that these things are going to exist, that when I click this button, the server needs to be able to do these things. And even if it doesn't exist right away, you can at least, there's no surprises down the road, right? You build it so that when this stuff exists, it'll work. And like Landon and Eric, you guys did this weekend, you guys designed, Eric, I know you designed the CSS, not that it didn't exist yet, which is hard to do, but you start thinking, if a message comes from this user, it looks like this, if it comes from that user, it looks like that. Before that notion even really existed in the JavaScript, but you can kind of think ahead to what it's going to be like and design as though that stuff existed. Because it will take a while for the backend to get running, and then once that's running, it's probably going to take a while for the front end to catch up. And that's just the nature of development. So the API is the place where these things, so as long as you agree on what that's going to look like, they can kind of proceed in parallel to a degree.
Backend size, I like setting the server.
Yeah, so I set up a server a lot like this for you guys ahead of time, but it's the same exact type idea. Actually, some of you guys, before I gave you the URL, you started building, and then you said, like, we can't get much further without the URL, right? So as soon as you have the URL, you can start moving. But without the URLs or knowing what type of URLs are going to be coming, chances are you're going to have to rewrite some stuff if you don't agree on that early. Or spend a lot of time waiting for each other, which is no fun. That's what actually happened a lot with people. It wasn't supposed to be a punishment. Yeah, it's so boring. I'm just kidding. Practice when you're trying to quickly build something like over the course of a weekend. If you have to wait a day for the backend person to come back from like hanging out somewhere, and you're not able to make any progress, then that slows everybody down. So.
Yeah, this is really strange. I don't remember ever having really any issues with this before. It is very strange that like my indentation's all screwed up. Something really weird is going on inside IntelliJ right now. But I'm trying to ignore that and move forward. Why is it? Oh, that guy right there. I have two currently running applications.
Here we go.
Locally, yeah. Local hosts.
Also, did everybody get the HQ email about free lunch today at 12:30 downstairs? Yeah, just saying.
All right, so it looks like we have things running locally. That's good.
Yeah, new member lunch 12:30.
So after the fourth git push Heroku master will work. the way we expect. All right, and then / coffee shops. Okay, now Luke.
Hey.
It's a good first step.
Yes.
Perfect.
Yay.
Yay.
So I'm console logging an array of objects now. Oh my goodness, 4 objects. If I refresh, 5 objects.
Really easy to do, man.
Yeah, it was super easy.
Yeah,
So
that was
easy.
awesome.
You guys didn't mess anything up, don't worry about it. That's what we say in programming.
We also say if you don't get it right first, you're a failure.
Okay, so I've got an array of objects. Instead of console logging them, I'm going to want to render them into this list. I'm going to use a loop for that, because we notice how many copy shops are after I refresh this a couple more times.
Coffee chops.
Copy chops. Copy shop. Is less than shops.length at. What am I doing? What's that? Yeah. I'm going to create an LI. I'm just going to stick some text in there. Text content is going to be shops I dot. Is going to be one of these objects. I'm going to grab the name, let's say, and then I'll say the rating as well. Shops I dot name. I dot stars. Kind of a weird hodgepodgey sentence, but it's going to say restaurant and then parentheses 5 stars or 4 stars or something. Oh, and then I'll end it to appearance.
Oh, you didn't need to close that? Yeah, but like the. Oh yeah, okay. Well, I guess you didn't need to close that like before you added the shops I got rating.
So this is string concatenation here. So this parenthesis isn't a JavaScript parenthesis. This is literally the character of parenthesis. So I want it to be restaurant name, parentheses, 5 stars.
That's cool.
And then, so we're going to need a parent to append this to. We're going to say document.getElement by ID. As a shop list. Yeah. Pre-selector. It is 2016. You're right.
You're gonna replace those shop.
Just get rid of those. It's not going to replace them, but you're right that we don't want them there. Inside of my for loop. And child adoption of. Oh, yes, but I need to put that there. Yeah, so you can find anything using a CSS selector. Check it out! If I just refresh. Yeah. Where do you guys want to go for coffee? So I'm going to get rid of before that.
Ooh, I want to go to shop 2. Oh no.
Shop 2. Sorry, they literally just closed. Yeah, the whole company actually, they had these other branches. So I just deleted those, and now all of these are being rendered from my Ajax response, right? So I've got this, I'm still actually printing this out, and I've got these objects, 16, I guess, for each one, right? But now Ben changes the backend. Since it's formatted in the same way, I'm going to be able to render that stuff automatically. So if he changes the way that capitalization works in names, or if he changes the way that ratings are computed, I don't have to change anything, right? He's just passing me the rating. I'm like, all right, whatever you say, I'm going to make that show up. that's kind of weird.
Why do we have like a million not just copies though? So how would we change that so that we can change, like, so that not just copy is running?
On over to you, Ben. Actually, before you do that, can I set up a post form so I can actually send stuff to you?
Yeah, sure.
Okay, so we'll come back and make it so that that works. I'm for now actually going to add another section, which is going to be the copy zone. Yeah, copy creation zone. CCZ. So this is where you go. You scroll down to the copy creation zone. This is going to be a form. I don't think we've talked about forms specifically. In fact, I'm not going to use one. Text box. This is going to be shop name. Oh, I can't use that. New name. Placeholder. Shop name. So we're also going to add two more, which are going to be number fields, and then we're going to have a submission button. Maneuver. Yeah. Number, new rating, new price. Mine. There we go. Oh. Name, rating, price, and then I'll have a button that's like the new shop button. So I'll click this, and it needs to send some stuff to the back end. Oops, awesome. Yeah, so it's going to be creating a new coffee shop that did not exist before. That means a new function back here called add new shop or something like that. Okay. What's this one going to do? Well, pretty much everything that this one did. I'm going to get rid of my load. I don't care what happens after a load. Make this a post request. The same URL, right, then? For post.
Mm-hmm.
So I'm not going to change the URL. So the server is going to look, if it's a GET request, it's going to return the array list of copy shops. If it's a post request, it's going to add a new thing to the array list. So I've got this add new shop function. I need to send some data. Pretty dead. Actually, I hate it, but that's real. That's actually what it's called. How you serialize in JavaScript. So we're going to serialize an object called shop, convert it to JSON, and send it over, just like we would have a chat message. Now we've got a 3 property object, right? We've got a name.
Or refer to the object after space included.
Dual squigglies would be an object that has no properties.
Right. Just make them side by side.
Spacing won't matter. Yeah, spacing won't matter. Where am I getting a name from? So I'm going to get it from this new name gadget here. Query selector, yes, sir.
So why do you use query selector instead of?
We're going to do the same thing as long as I put a hashtag here with the ID of new name. The element by it.
Where's like you're replacing all those? You can forget like, you can forget like 2 or 3.
Yeah, I mean, you can also do this with ID. It's converting it into one line, which is nice. To rating, and then there's going to be price. Right. So pulling from 3 different fields in the document, right? Getting the value, which is whatever's typed into the text box, stringify into a JSON string to send over to Vin. It's not going to work because Vin hasn't made it. Oh, I also haven't finished. I need to add an event listener to the button. Another query selector. The only button on the page. That's probably a bad idea because if another button's never added, then this is probably going to break. But since another button isn't going to be added, I'm just going to say when this thing is clicked, call add new. So now I should see when I click that button. Let's add another copy shop. Let's call it not just copy.
Get that.
Rating 1, rating 8. Job. It's going to be like, oh, that doesn't exist. Post to that URL. But I can go look in my network tab, see that I was, in fact, hopefully, sending an object that has a name, a price, and a rating.
To the backside? Okay.
Yep, Vin's just not listening for it yet. So it came back with a 404, which means that URL doesn't exist.
Oh,
I'm
okay.
gonna, actually though, before I do this, since I'm gonna parse int, since technically rating is an integer.
So listening is the go between front end and back end.
Yeah, so Vin server is set up to just for other people to talk to it.
Like online. I never knew what that meant.
For today. No, it's actually very, very exciting. It's insanely cool how all this stuff fits together. We should fix this bug next. But yeah, now I can make this request. It's going to fail because Vin's not listening for it. But as soon as he starts listening for it, technically it should add it to the array. Then the next time I make a GET request, it's going to be there.
Oh, that's cool.
On over to you, Vin.
Well, we actually have an issue that I'm trying to look through right now.
Ah, sweet. Okay.
Actually, wait. Let's try to change this to params instead.
Do you have any questions about this code? I wrote it up pretty quickly. Looking at the other. But this, so the pattern here follows very closely to what you guys did this weekend, right? I think there are major deviations.
So let's check this out here. Oh, you know what? What I was doing was just setting this up to look at query string parameters temporarily, so I could debug like the actual logic of what's happening here. So that's what I'm doing. So I thought that the Spark framework had a unified way of accessing parameters, whether it be via post submission or query string. But apparently, it just specify. I think they recently changed that actually. Okay, so so I had another test endpoint here. Good. All right, good. So sadly, we need to change this to params. All right, so we're going to change this to post. Then this is get. I'm going to change this back to get. Back to. problem that we were experiencing before that Luke was demonstrating was that every time on GET request, we were adding a new element to our shops list, which was completely arbitrary, not based off of actual data, right? You see here on this line 37, that's what we're doing. We can't do that. This is a GET request. That's a big no-no in GET requests, is updating data on GET requests. So you can't, it's typically not a good practice. And you saw why. Every time we refresh the page, and if everyone can do that and hit the website, then all of a sudden you'll have like 10,000 elements. Right.
We want to add on posts, right?
Yes, add on, but you create new objects with post requests and then put and update our, like you edit existing ones. Okay. You see here on line 36, let me share my screen actually at this point. We're still making a new JSON object, and then we're returning shops, which is an array list. We define shops up here, but we only add to it on our post request here. So we specify post here. The URL is /coffeeshops. Already a string, so it need to be converted or casted. Basically, what we're going to do is take the parameters we pass in through our post requests that are called name, rating, and price variables. Then we're going to make a new coffee shop based off of name, value, and price, and immediately add it to our shops list. And then we're going to return 200, which just says status code is okay. So let's go ahead and test this. Switch back over here. That real quick. Add. This stuff to Heroku. That's the posting yet. Hope for the best.
So now I've got those two endpoints. One is a push request, one is a GET request. It was already working just by typing stuff into the text boxes and then clicking the add button. You also see that all those copy shop things are going to go away just in reset the server.
Yep, you see, like, you refresh the page. My log files now, so every time he updates, or every time he refreshes, I can see there's an entry here. It says request is /coffee shops. Where it's my domain. I can get forward from this URL, this IP address, or whatever. So yeah, basically, see here we have the method equals get. Because the page, that's the method that it's going to be using, right? So Luke is going to submit his information. We're going to cross our fingers and stack trace, which is awesome. And number format exception on main.java line 47. This rating. What was the format of the data you sent to me?
Name was a string and then rating and price were both integers.
Really? Okay. Let's double check the Spark framework for posts. Okay. Never mind. Man. Man, the crappy part about this is no real great way to debug it except for to redeploy it to Heroku every single time. Postman. So let's Google Spark Java post request variables. So we have query params there. There we go. Looks like they're using params here. Fields that you included.
I had a rating and price.
Price and rating. Yeah, that's exactly what I'm expecting. Let's do. Okay. Let's just print out. Yeah, I guess so. It's kind of a proof of concept. That's what problem with Spark. Really thought it was params, so that's basically everything. Okay, can you post it again? Yeah, it's null. Well, I don't want to keep everyone here while I sit here and debug this. So sadly, I might have to take a look at this after we go to lunch, and then I'll have it fixed by the time you come back. Figure out exactly what's going on, what method call I need to make inside Spark to actually make this work. But when you do post data to this endpoint, the general idea is that you get the fields from your request, add it to your array list at this point, so that you don't add it every time you do a GET request. So
And that's the same array list that you'll be returning from GET requests.
Yep.
Okay.
So I think it's time to break for lunch. I want to figure this out real quick before we head anywhere.
Yeah, sure. So at a high level, just, I mean, the main point here, A, is that you guys are out there, find APIs that are literally APIs that you can use for all sorts of things. Your own APIs. Name them, the path to the URLs are arbitrary. Consistent between the front and the back. Like you guys are going to be doing a lot moving forward. Agreeing on the APIs is essential. Agreeing on them early and giving them thought early will save you a lot of time. This code, so you guys can look at it. We went through the code itself pretty quickly. Totally new. I know that's going to be doing a lot of Spark this week. But anyway, hopefully this feels as powerful as it is, because this is where you can actually start doing really cool stuff. Cool. Break for lunch?
Okay, dude.
Sounds like we got free lunch downstairs too at 12:30. If you guys want to go to that, those are generally pretty fun. New members' lunches here for like 10 months. I'm not sure if I'm still welcome. They haven't kicked me out yet.
All right, stream. Thank you for watching. I will catch you later. Sorry about the at the end, but we'll get it sorted out. We'll push this code to GitHub. See you later. Have a good day.